This conference will now be recorded.
Sorry, you are in mute.
Now it's unmuted.
Yes, sir. Fine.
Yes, sir.
Okay, thank you. So I asked about actually, but I think I was on mute when I asked something. I asked about does anybody knows anything about system call? What is called system call?
Which system, sir?
System calls.
Collection of elements or components that are organized for a common purpose.
Component or
Collection of elements or components that are organized for a common purpose.
Mhm. Okay, fine. Let me go ahead and give some example. Before example, let me say some in few words. System calls are function which connects you. We know that we have in operating system we have one user space, kernel space, kernel space. You cannot talk here. You cannot directly go and write down anything in kernel space wherever your all your driver and everything is running. Your whole component or your whole core components are running. You cannot directly go and write down here anything. you are given permission to execute application, write down something here, but not here. So to write down here, you need a system call. So what does it mean? What does it mean by write down here? Writing down here means like you have RAM. RAM has access. Kernel can only access this RAM. User space directly cannot write into the RAM. User space need to call a function call. Let's say write. Okay, write will happen. Write will happen with some which file you want, what data you want to write, what is the data of size you want to write. All these things you have to write out in this argument. So it will go, it will check the memory area, it will write it down. And now it's kernel's responsibility to write it down from here to your RAM. And actually, it's first when you are giving a write, it's getting written on RAM, and it's kernel's responsibility when you are pressing Control S to transfer this data to your hard disk. So first, whenever you double click and open a file, it gets loaded from your hard disk to RAM. And now you will have access to whatever the data here you have in kernel space only. Whatever you are seeing is a presentation of whatever that application is trying to show you. Whenever you scroll up, scroll down, read system call further blows there, and read system call gives you an access to read all the files, content of it, and show that in your application. Let's say if you are using an editor called VI editor, which is displaying your content, so that's doing a read call and displaying the content. So this is what a typical system call goes. And for writing anything, reading anything, or doing anything in the kernel space, you require system call. Without system call, you cannot do anything. So this is the basic two system calls I have explained. I mean, not explained even, but just given a basic what is write and what is read. And these two are actually a system call which talks through, which you can write in your C program and talks through the device or a particular file which. Yep. So this is what a system call. Now we'll go back to our previous topic where we have to see what is system call and the context of it. Okay, so here we have system call. Okay, so when we do a system call, now everyone knows what is called system call. Whenever we read a file from any of the method, it goes through read or write system call. If you want to write something, it goes through write system call. If you want to read something, it goes through read system call. Okay, with several arguments. So now let's say we are having a system call which checks SELinux status. SELinux comes in between here. And let's say if you have, let's say if you have SELinux enabled, in that case it will check SELinux is enabled or not. If it's enabled, then it's okay. It will go ahead further. Here we'll go ahead. If it does not enable, it allows the access directly. Go and access that file. Let's say if it's enabled, then what happens? If it's enabled, If it's enabled, it goes and checks the log, not checks the log, it access the logs, whatever you are trying to access. Let's say if you're trying to access one file, it goes and say that, hey, in audit.log, it will say that you are trying to access this, you have permission, you don't have permission, or you are not doing things in the right way. So from here, after logging, it will check the SELinux mode, whether its permission is it is permissive or enforcive, or it's denied itself. Yep. So it checks the security level of SELinux. So if it's permissive, it means whatever you are trying to access is allowed. Okay, it's allowed. It will give you the permission. If it's enforced, it means like it has to go through the security checks, whatever has been enforced. Then it will come. It will check the policy. If the policy says it's allowed, you are once again permitted. If policy says if it's not allowed, you will not be permitted to access that. So this is what the three things, and this protects in a very large way. Let me give an example again. Mm, okay, let's say you have your system. Okay, in that you are having a hard disk. You have kept lots of files, and you are running your FTP server. You are running your FTP server here, and then which gives access to these files. Okay, so if FTP server, if let's say if your what to say, yep, let's say if SELinux is enabled, okay, and it's enforced. So in that case, you, if somebody wants to try, somebody is trying to access this file, which does have SELinux enabled, he'll be able to access. And if this is SELinux, in SELinux, if you have disabled or if you have removed read or write permission from SELinux, even though even the FTP has access to this,
Sir, you are mute.
yep, even though if FTP is having access to this folder or this file, SELinux will prevent you, SELinux will stop you accessing these files because it's not permitted. Same thing happened for HTTP also. I mean, in fact, you will see this difference. You will see this difference. That's why I'm giving you these two examples actually. In HTTP, what happens? Let me tell. In HTTP, it it gives it's an HTTP. It's a web server actually. When you are required to host a web server, you have to install HTTPD and then you need to start this service. So after starting this service, what it does is it has a file that's called index.html. This file, HTML file, gets hosted. What is the meaning of get hosted? Is whenever you open this IP, let's say I'm doing this HTTPD installing in this system, and this system does has an IP called 10.10.3.8. So let's say this system is having this IP. So in that case, in this system, HTTPD is running, and in HTTPD, we are having a file called index.html. So whenever you will try to open this IP in another system or in this system also, no issues. In this system, you are turning on a browser, let's say Chrome. Here also you are turning on Chrome. So what will happen when you try to use this IP? It will give you a page. Of what page it is going to give? It is going to give you index.html page. Whatever the content you have written in the index.html, it is going to give at both the places. Here also, same page. Here you are opening your self IP. Okay. Here you are opening other computer IP. But at both the places, both the places, what we are trying to access is the same thing. And here a server is running. HTTP server is running. HTTP server is this one. And what is the work of HTTP server? HTTP server work is to host a website. And the website main page is index.html. So whenever you see this page, it hosts this file index.html. And from index.html, whatever page you wanted to go, you can go there. It's like you wanted to redirect to some other page, you wanted to give a menu page, or whatever you want to do, you can do that. It's up to you. So in further, you can create lots of links in index.html and you can redirect your files. So having said that, where this file stays, it stays in var www. Sorry, it's not var www. It's var. It's HTTP, then www, then HTML. Just let me check. Just 1 second, please. So that file location is not this actually. I missed that. This was the correct one. Var www/html and then /index.html. So this is the file location. So what happens? Why I'm saying all this location and all? So whenever this gets installed, and if SELinux is enabled, SELinux will permit by default in HTTPD settings, we have given a permission to www.html and index.html file. Let's say somebody wants to move this file and keep it in slash slash opt, though this whole folder www slash html slash index.html. Somebody wanted to give this, and he thinks that we will be able to access this website from here as well. No, you cannot. So after moving, you need to update this location in html.conf file. After updating also, you will not be able to access this. Why? Because SELinux will deny this. Whenever HTML server comes, HTML, whenever from here request comes to HTML, sorry, request comes here on HTTPD, HTTPD will look for html.conf file here, and html.conf file will look for the location, which location I'm pointing to the, for looking at index.html file. So conf file will see that I'm pointing to index.html at this location. It will try to access, but it will get access denied because we don't have SELinux permission here. So same thing is for FTP as well. FTP is for downloading the files. So it's file transfer protocol, which is less secure than the other protocols. But the thing here is like using SELinux, we are trying to restrict a user to access only these files. If you don't have permission, you will not have access to this. So that's what the basic idea of SELinux here, what we are trying to achieve using SELinux. So let us go through the practicals, and before that let us understand the other aspect as well from the web browser, what we have seen here. Yep. So we can see the SELinux configuration file like this. Like SE status, if we type, it gives us the whether it's enforcing or not, whether it's enabled or not. It gives us this information. And after that, there is a file called selinux.conf. It doesn't show the location. Anyways, we can see, we can set or disable, we can set or unset like this also. Set enforce 0, and then if you see the status, it will say that permissive, like everything is permissive. Now you can say that SELinux is not, SELinux is enabled, but everything is permissive, not in enforced mode. But default, it will come as enforced mode. Yeah, this is the configuration file which I was talking about a second ago. vi/etc/config sysconfig/SELinux, where you are, if you want to disable the SELinux, you need to add this disable and then save the file, and then obviously yes, you have to reboot to take this into account. If you type this command get enforce, you will see that it's disabled. Here you can see that. Set enforce 1, you will see that set enforce 1, you can see that it's disabled. Set enforce 1, you can see it's 0, you can see that it's all disabled, because set enforce is enforcing, sorry, It's giving permissive. It's giving what are all two permissions actually? One is permissive. Let me go here. Yep, it's enforcing or it's permissive. So these are the two permissions which we can modify by using 1 and 0 here. Set enforce 0, set enforce 1. Sorry, set enforce 1 and set enforce 0. So, but here we can see that in both the cases it says disable. Why disable? Because our the whole SELinux itself is disabled. So either we set 1 or 0, it doesn't matter. It will be disabled. So ultimately we have to enable the SELinux from the config file, and then we need to save it, and then we need to start it. So what do you do in a regular looking at the list of file? You run ls space hyphen l, which shows you the list like this. So if you want to see the SELinux context, you need to run hyphen z, ls hyphen lz. So which gives you all these things, all this information. System underscore u, object underscore r, admin underscore home underscore t, and then s0. So for some things it will give like this. For some it may give like this. So it depends on a different it can be based on condition. We might have seen the permission for netstat also. We might have used netstat for looking at the open ports. Yep. We might have used netstat to look at the open port, or not even open port, but before open port we need to look at whether my server is listening or not on that particular port. So to check that, we might have run this program, run this command. If we add z in that, it gives us the SELinux permission for that particular protocol. Now we'll understand what are all those permissions. So for PS also, PSOX we might have run. If we add with ZOX, it gives us the permission of that particular process. So you can see that SELinux is tightly coupled with permissions, sorry, processors, sorry, not processors, process, as here SELinux is tightly coupled with process. It's coupled with network protocols. It's coupled with files as well, individual files and folder as well. So yeah, here we will have user part. So let's understand what is called user part. So when we see underscore u ends with, it's the user account presentation of SELinux context. So we call this portion as a SELinux context. Whatever it shows first, system underscore u colon system underscore r kernel underscore t, then s underscore 0. So if we have u, it's the role type. Sorry, it's the user account. It's a system account. Here, if we see system, it means like it's the system user account which has created or which has been using that. And okay, this is a key point here. To manage the level of permissions, SELinux uses user accounts. So different user accounts SELinux will uses to manage the permissions of it. Okay, so we can understand some of the theoretical concept here. SELinux user accounts are different from the Linux user account. We will be able to log in on multiple user accounts. So SELinux user account are different from the Linux user account. We will be able to log in on multiple user accounts. Yep. So SELinux user account are different from the normal Linux user account. So in normal Linux user account, we will be able to log in. But in SELinux user account, we will not be able to log in. We will not be able to get the shell prompt. SELinux users are defined in SELinux policy and load in the memory at boot time. So this is another key point, that whenever we restart the system, if SELinux is already loaded, or sorry, it's already enabled, at that time, boot time itself, it loads into the memory the user defined policies, whatever we defined. SELinux user does not have login access to the server. So SELinux will never have a login access to server actually. So SELinux will not be able to log in. If you think that SELinux can log in into your machine or do something, no. SELinux just manages the permission based on certain user groups. That's all I can say as of now. Yep. So it's defined on multiple level of permissions. It's mapped with the SELinux user account. Each Linux user account is mapped with a SELinux user account. SELinux does this mapping in policy. You can see that SELinux does this mapping. So role part. So whenever we see underscore R, it means like it's a role. It's talking about the role. Role, we will have three things: subject, object, and domain to understand. Okay. A subject is a user or a daemon or a process which access the object. Now, what is object? An object is a resource, such a file, directory, hardware, device, or network application, which is accessed by a subject. Can somebody go on mute? Yep. Okay. So now domain, we are coming to domain. Domain is what subject defines, what kind of permission the subjects can have, whatever subjects we have set here. Okay, so let's come back here. We see that system underscore R. So it means like this process has been created by system, and system will have the access to this. And here we come in underscore R object. So this is the object actually. So this is the object, means like this is the file which a particular system will can try to access or cannot. That's different thing. But here object is, this is an object actually. When we talk about object, it means we are trying to talk about a file or a folder. That's what the meaning of here, understanding this. And when we talk about subject, it means like we are talking about a process or a daemon. So when we talk about subject, it means like we are talking about this process or this daemon or any daemon. This is a subject, and which tries to access this object. Now type underscore t is there, which ends with type, which tells us this what kind of object it is. So let's read it out. For example, a type for file defines what kind of file it is. Is it such as etc directory file, web page file, hardware device, or network file? Since type is the only part which is tested in RHG exam, what is this? We'll understand this part in detail with examples shortly in practice session. Okay, fine, no problem. So okay, so the type is actually what kind of object it is. I mean, it's a kernel object, or it's an admin object, or it's normal user, or any user will have access to that particular object. So the what kind of object that is, that's what this type is going to talk about actually. So now, okay, here I have told about some things, few things. I have told about two examples, FTP and HTTP. So here they are telling about this. Okay, we'll see that difference when we'll see ls-alz, the difference between the notation of FTP and HTTPD as well. Okay, so let's see. Okay, here is example. They're installing HTTPD. They're starting the service. Create an index.html in var www.html file, and they're going to write down things here in test file. And after that, after writing there, they are going to open this link, and this says that this is a test file only. Now they have shown ls-al somewhere, ls-alz. No, not yet. Okay, so they have named a file in this www and html is index.html. So they have kept the content of it. Fine, no problem. So they are taking the another example. They are they are printing the content of test1.html, and they are printing that content in test2.html. So we have test1 and test2. The content seems to be same, and the only difference is test1, the file name only changes here. So now what happens is he's trying to he's trying to copy the content of test1 to HTML, and now he's trying to move the content of not content, he's trying to move the file of test2. So you will see the difference. Actually, here at this point of time, you will say that we will have test1, test2. What is the difference in between? Some people can say that yes, we are moving a copy from here. Sorry, we are making a copy of file from here to this folder. In this, we are deleting this file and moving this file here. That's correct. But what is more than that? The more than that is when we are copying the file. Okay, let's go further down. We'll see that. Okay, let's see the difference. When we have tried to access test1, we are able to access this file. When we try to test, when we are trying to access test2 file here, which is giving us forbidden permission. Now why? Because when we copy a file, the SELinux permission of this HTML directory automatically gets enforced onto the copied file. But when we move the file from one location to another location, SELinux context is going to be get moved along with the file itself. So HTML will hold a file. For that, SELinux context is different than what the context of HTML is. So in that case, we will not have access to test.html. We'll see that here down. Now they are showing the example. What they've done, they are deleting the both files, RMF and RF test one. They have deleted. They have gone into HTML folder and they have deleted both the files. Okay, no problem. Okay, they are here. They are giving the practical example once again from starting. So here they are into the home folder currently.
Sir, not getting your voice.
Sorry. So here we have seen that they are into their home folder. Now, sorry, by doing CD, they have gone into their home folder. Now everybody understand that what is home folder of a particular user. Okay, so they are printing the content of test1.html file. They are printing the content of test2.html file. Now they are looking at the security context or SELinux context in home folder. You can see that in home folder. After that, you can see that unconfined underscore u object is this and admin underscore home underscore t. So admin home underscore t will have the permission. I mean, this is the object type, this is the role, and this is the user. Now here two commands are happening. One is cp, another one is mb in both the directory, or sorry, in the same directory, both the files. But cp is happening with test1, mb is happening with test2. That's what we have spoken about above. Now we'll see the difference. Actually, you can see the difference. httpd underscore sys content underscore t and here admin underscore home underscore t. So when we moved the file test2, the context also got moved along with the file. You can see that here. What is the context and admin underscore home underscore t, that has also moved. But when we copied the file, here we are copying the file, and this was the file we are copying actually. So sorry, this one. So when we copied the file, we can see that it has inherited the security context of whatever we were having of the slash var slash www slash html. Whatever the security context of here is has got updated for copying. Okay, so if we change this context, sorry, if we change this admin underscore home underscore t context to http underscore sys underscore content underscore t, then definitely this file will also be accessed from the web browser to other people as well. So that's what at this SELinux, it's an added extra security layer to enhance the security by giving different context. sorry, by giving different layers, not layers, I should say that by assigning different security policies at a context. So we'll see the commands. What is the command? chcon is the command which we'll use. -r apply changes recursively. -v, okay, fine, verbose. -u, we are going to set user context. This is what is important for us. If we wanted to set a user context, set user context like this, set role context like this, set type context like this. This is what we will need: user, role, and type. So we were having a role called admin home team. We wanted to change that to httpd sys content underscore team. That will be able to change like this: httpd underscore sys underscore content underscore team. By using hyphen a is amend, hyphen t is type, and using ft context, sorry, f context, not ft context. By using this command, we will be able to change the permission of this whole directory itself. So yeah, that is the example for changing the file context. And if you want to find out the file context, this is what they are giving us: the context directory. We can get it from here: SELinux targeted and then / context directory. Which file will have what context, we can get from here. So this is all about SELinux actually. I want you guys to perform this operations actually. Perform this practical, not even this one. Before coming to this, I want you guys to perform this practical. And I wanted to see that how many guys are able to perform this practical, and then further we'll proceed, because this practical will require lots of troubleshooting you have to go through, and I want everybody to get your hands dirty in this. If I'll tell, even though everything is written here, that's not a problem. When you will try to successfully perform all this operation, you will face many issues. Then you'll come back to me, or you will try to resolve your issue on your own. That's way that's the way which shows that yes, you are working and you know something. So I will not give practical for this. I will see how many people are able to complete. If you guys are able to complete, that's well and good. If not, and if it requires practical or a lab, I will conduct a lab again for the whole session. Theory part is done. So based on need, we will conduct the lab part. Okay, having said that, we were having a issue in yesterday's session, correct? Let me open the session file. I have recorded a separate, but I'm not sure if that has already been uploaded or not. I will check and will make sure that that gets uploaded by today itself. But let me demonstrate that problem here. We were in RPM build, correct? Yep. So cd space RPM build vi it not etc vi specs hello.spec. So this was a spec file. Actually, the problem was in build or I have given a tab. What is called that? This is tab. I should not give tab. I should give spaces and then closed it. Yeah, and another changes what I have done here is here it was using an arguments underscore bin dir which RPM test was complaining that build dir not able to find out. So rather than giving bin dir as an argument, I have given the absolute path slash user bin slash user underscore slash user slash bin. So I've given the path itself. I've told them this is spec file to change to check the name. It was complaining here itself. I'm not sure what has went wrong here, and then it was started complaining. You can see that here it's not complaining. I have given the same thing. So okay. Anyways, this solves the problem. Remaining thing seems to be the same. No issues, no changes. I'll close, and then if I will run rpm build -bb hello.spec, it's going to successfully build a RPM file. You can see that here it has built a successfully RPM file. Hello hyphen this is dot el7 is for CentOS 7 dot no arch dot RPM. It means that this is not for any architecture. I can install this file in any architecture. Okay, I have already installed yesterday. So let me remove that. Okay. So now we have the file. Now we have the file, RPM file. Now we need to install. So how to install an RPM file? RPM hyphen ivh space build hello hyphen one. After that, what is the location? I forgot that. Let me see. Oh, RPMs. No arch. This is the RPM file which we need to install. Okay, we'll install that. Now I'm pressing Ctrl S. I want to show you that ls hyphen ls space slash user as bin. Hello. We don't have any file, correct? Now after installing rpm space hyphen ivh space rpms no arch hello. After installing, we will be able to get our hello file, which we have written yesterday. It installed successfully. Okay, it's already installed. So let me remove that. Yum remove hello. It's got removed. Okay. Now let me install it again. Yep, it's installing and it's installed successfully. It does not throw any error that it's already there or something like that. Now we'll see that using ls whether we have that file or not. That's not encouraging. Uh-oh. It has kept in bin, it seems. Yep, it has been kept in bin rather than as bin. Okay, because sbin it complains about file not existed or moved it, so system automatically kept that in bin itself. You can see that. So we have slash bin slash hello, we have this file, and if we enter just hello command, it will print hello world. That is what we have typed yesterday. So similarly, you can bundle any binary in this RPM file, and you can ship this to any system or to anyone. I have written just only one hello underscore script, but if you wish, you can write it down whatever you want. This understood? Any doubt here in this?
No, sir.
Okay. So let's stop this session recording here.